Hello guys, welcome to the first video on this YouTube channel, and on this channel you'll find that most of my videos are either math or Python related, or a mixture of both, and you'll also find that in all of my videos there will be timestamps in the description which you should always check out because I know what it's like to go through a video at 2x speed or skipping through it, and I don't like doing that. So I'm gonna hope that none of you guys will ever have to do that in my videos. So let's get started with a proof of the formula of linear regression. So we've probably seen some kind of coordinate plane like this before, and you probably realize that this x-axis is something that is causing something in this y-axis, and the way that you can tell that is because they seem to fit a line pretty well, right? So like there seems to be a relationship between these two variables. So at just first glance we can tell that the line that seems to fit them best is the line of equality, y equals x. But it's not actually the correct regression line because, of course, you can find the line of best fit mathematically. And this is actually the line of best fit for this data. And that's because the sum of the squared residuals between this line and these points is lower than that of this line and these points. And what do I mean by the sum of the squared residuals? That probably sounds pretty intimidating or whatever. And it basically just means, so a residual is the difference between the predicted and recorded values. So the predicted value would, in this case, be 6.218, and the recorded value is 7. Here, the predicted is 6, and the recorded is 7. So clearly, there's less of a difference between the purple line and the green line between these points. So what do I mean by squared when I said sum of squared residuals? So the line of best fit, using the least squares method, finds the line where the values of these residuals, when they're squared, are the lowest. Okay, so you may have seen this formula before. It's the formula for the line of best fit for a group of y's and a group of x's, and it finds the slope and the y-intercept of that line. So let's just kind of figure out how that came to be. So you can start by understanding that we're trying to find a value that has the lowest sum of the squared residuals, which means this function e is equal to the sum of the observed y minus the predicted y squared. So then you can kind of break this down, this y, into mx plus b, because that's really what we're finding, right? Y equals mx plus b is the equation of a line. So then this becomes a function of m and b. So just when I have this, it means that the inputs to this function are m and b, and it outputs the sum of the squared residuals. Actually, I'm going to do this. And the reason why I did this is just so that, so why I did it in this order is, first of all, because a minus b squared is equal to b minus a squared, and second of all, because then you don't have to worry about parentheses and stuff like that and multiplying out negatives, and it'll give you the same final answer, but it's a little more complicated. So if you want to follow along, multiplication is a little bit easier when you do it this way. So then you can actually multiply this square out, and oh boy, my fans are running. So this is what you get when you multiply this. And now we have to do something interesting with this equation, because we want to make it something that we can compute, something that we can actually find the answer to, and we don't know the values of m or x or whatever, so we can't find the value of e. So only known values, such as x and y, which we are given, which we're treating as constants, can be summed up because we already know what they are. So let's say we have the sum of x plus y. And then the x values can be 1, 2, and 3. And the y values can equal 4, 5, and 6. And basically you would, if you actually follow this sigma notation, you'd get 5, which is 1 plus 4, plus 7, plus 9, right? But what would you get if you do this? Well then, so actually this is equals 21, just for that. Then you would get 6 plus 15, which also equals 21, right? Pretty hard to believe, but it's true. So now we can use this property to rewrite this equation. And it'll look a little different from what you'd expect, but just wait until I've written it down and then you'll understand. I'll explain exactly what I did. So that is kind of what we found when we distributed the sigma the way that we proved is possible over here. So how did I do this? What did I do? So I distributed the sigma to each term. And as I mentioned earlier, we can only have sigmas around either x or y. So then I used another property of sigmas. So we have the sum of x, y. How can we prove that this right here is true? Well, you can use the distributive property, because basically right here, x would be being multiplied by y1 plus y2 plus y3 yn, right? And this is equal to y1 and then plus x being multiplied by y2. We know this because this is a distributive property. But that's only if x is a constant and y is a list, right? Oh, so we've kind of proven this right now. So then actually what would this be? That's exactly what this is, right? Because this is exactly what you would do to compute this. You would multiply x by each of the y values and then add them all up. So that's why that's true. Let's go back to where we were before. So now all this b, m stuff, that there's only one value of b or m, so you can take that out because that's equivalent to our x over here. So now what about this term right here, nb squared? What does that even mean? So we have b squared here, and we're summing it up because we have this sigma that we're distributing all the way over here. So why is this now nb squared and why is it not sigma b squared? B is only one value. So if you're summing up all the values of b for every point in our set of points, it would just be b plus b plus b plus b n times, which is just multiplying b by n. Sounds legit? So now we have this equation, and we need to find the values of m and b that create the least possible value of e, because e is the sum of the squared residuals between the line mx plus b and the points that are given to us, x's and y's. So from here you can write this as a function of first m and then b. So we can start by writing it as a function of m. So we can group terms according to m raised to the nth power. So the highest power that m is raised to is 2, so we can do all the terms that contain m squared and multiply them by m squared. So we're essentially grouping terms. Then we can go for the terms that contain m. So whoops. And that's it. Then you multiply this by m, and then you add on all the remaining terms. Now we have our function of m, and now we can do the same for b. So these are two functions of m and b. And what you can notice, if you haven't noticed already, is that they're both parabolas because they follow the format ax squared plus bx plus c. So now we're trying to find the values of m and b that give the lowest value of e. So what you can do is you can see that this parabola opens upwards. So the sum of the x squareds is obviously going to be positive because x squared is always going to be positive. And then n is always going to be positive. So the value of e that will be the lowest will be at the vertex point. So if you've taken algebra, you probably know that you can find the x value of the vertex of an equation by solving for negative b over 2a. And I won't really go through that whole process, but basically you end up with the exact same thing.